Hey there, and welcome to The Explainer. Just for a second, look around you. Your phone, that chair, maybe the cup of coffee you're drinking, almost everything. It all started from the same place, a master blueprint. Today, we're going to pull back the curtain on that blueprint, engineering design.
So, have you ever really thought about it? How does something like your phone, something so complex, go from just an idea into the thing you're holding in your hand? It's not magic, it's a process, a really structured but also super creative process. And that's what we're going to unpack today.
So what is it really? Well, at its core, engineering design is basically the ultimate form of problem solving. You know, it's this amazing blend of art and science. It's taking all that heavy stuff, scientific principles, mathematical analysis, and then you sprinkle in a ton of creativity to build something that actually works in the real world and solves a real problem.
All right, here's the game plan for this explainer. First, we'll nail down what engineering design really is. Then, we'll walk through the 10-step blueprint that makes it all happen. After that, we'll look at the team, the people who bring these ideas to life, and the mindset they need. And finally, we'll tie it all together and see why this stuff is so important.
Okay, so Section 1. What is engineering design? You can think of it as the ultimate roadmap. It's how you get from, hey, there's a problem here, like getting across town is a pain, all the way to a concrete solution. You know, like a brand new electric scooter.
All right, let's get into the nitty-gritty. Section 2, the 10-step design blueprint. Now, this isn't just people throwing ideas at a whiteboard and hoping for the best. Nope. There's a formal process here, a map that takes engineers from a fuzzy idea to a real working thing.
And yeah, that journey is almost always broken down into 10 key stages. And what's wild is that it doesn't matter if you're building a massive satellite or, a better can opener. The fundamental map is the same. So let's walk through it.
Okay, so the first half of the journey, steps 1 through 5, this is all about the brain work. It's the think before you build phase. First, you have to define the problem. I mean, really define it. If you mess this part up, the whole project is doomed. Then you do your homework, the research, so you're not trying to solve a problem that someone already figured out. After that, it's brainstorming time. You go wide, generate a ton of concepts, and then you start narrowing it down to pick the one that actually makes sense. And finally, you develop the detailed design, the actual plan for building the thing.
And now for the fun part. The second half is where things get real. Step 6, you build a prototype, your first physical version of the idea. Then comes step 7, you test it. And I mean, you really try to break it. You push it to its limits. Why? Because you want to find the flaws before a customer does. Step 8 is optimization. You take everything you learn from breaking it and you make it better, stronger, more efficient. Only then, once you're confident, do you move to implementation, actually making the thing. And last but not least, step 10, it's not over when it ships. You got to present it and then maintain it for the long haul.
Okay, now this is super important. This 10-step process, it's not always a straight line from 1 to 10. In fact, it rarely is. It's what we call iterative. It's a loop. So imagine during the testing phase you find a major flaw. Well, you don't just patch it up and move on. You might have to jump all the way back to step 3, the concept stage, and rethink things. This looping back, this constant refining, that's the secret sauce. That's how you get designs that are truly solid and reliable.
Right, so a great blueprint is one thing, but you need a crew to actually build it. Which brings us to our next section, assembling the design team. So who are the experts that navigate this whole process? Let's meet the key players.
First up, you've got the design engineer. This is your primary architect. They're the ones who take that initial spark of an idea and start turning it into actual, concrete plans. Their whole world revolves around making sure the design is safe, efficient, and, actually works. But let's be real. Most things today are incredibly complex. Think about your car or a new laptop. It's not just one part. It's a whole bunch of systems that have to work together perfectly. And that's where the systems engineer comes in. They're like the orchestra conductor. It's their job to make sure the engine, the electronics, the brakes, all these different components are playing in perfect harmony.
Okay, so you've got a killer design, all the systems work together, great. But now you have to actually make it. And not just one, but maybe thousands or even millions. Building one perfect prototype is one thing. Building a million identical, high-quality ones is a whole other beast. And that is the world of the manufacturing engineer. They figure out how to set up the factory, the assembly line, the whole process to produce this thing efficiently and consistently.
So we've got the process, we've got the people. But there's one more piece to this puzzle, and it's a big one. It's the mindset, the core beliefs and philosophies that guide the entire journey. This is what separates a good design from a truly groundbreaking one.
When it comes to mindset, there are two big approaches you'll see. On one hand, you've got linear design. Think of it like a waterfall. You complete step 1, then you move to step 2, and you don't go back. This is great for things with super clear, fixed requirements, like a bridge. You can't really get halfway through and decide to iterate on the foundation, right? On the other hand, you have iterative design. This is a cycle, a loop. You build something, you test it, you learn, you refine it, and you go again. This is perfect for something complex and new, like designing a drone, where you need that flexibility to learn and adapt as you go.
And that leads us to a really powerful philosophy that's taken the engineering world by storm: design thinking. The idea itself is actually pretty simple, but it's also kind of radical. It's all about putting the human, the end user, at the very heart of everything. It shifts the question from just, hey, can we build this thing, to the more important questions. Wait, should we build this? And do people actually need it?
And the process for this is just beautiful. It starts with empathy. And I don't just mean looking at spreadsheets. I mean really getting out there and understanding what frustrates people, what they need. Once you have that, you can define the real problem you're trying to solve. Then you ideate. You brainstorm all kinds of solutions. And then, and this is key, you quickly build a simple prototype and get it into users' hands. You test it, you watch, you listen, you learn, and you start the cycle all over again.
And this whole human-centered philosophy is a launchpad for so many other important design approaches. Things like inclusive design, which is all about making sure what you build works for everyone, regardless of their ability or background. Or sustainable design, which thinks about our planet's resources. You've also got ergonomic design, which focuses on comfort and safety. You know, the reason a good office chair feels so much better than a cheap one. It's all connected back to the user.
Okay, so after all that, the process, the team, the mindsets, let's land the plane. Why does any of this matter? What's the point? Well, the goal is actually really simple, but it's also incredibly profound. It's about making things better.
So here's the big takeaway. Engineering design isn't just a 10-step checklist. It's a dynamic combination of 3 things: a structured process that gives you a map, a skilled team that can navigate it, and a human-centered mindset that makes sure you're heading in the right direction. When you put all those pieces together, that's the engine of innovation. That's how we turn massive challenges into solutions that can genuinely change the world.
And that really just leaves us with one final question to think about. Problems are all around us, right? From the little annoyances in our day to the huge global challenges we face. So, what problem in your world is just waiting for someone to apply the right blueprint? Thanks for tuning in to The Explainer.